Okay, we're going to deal now with what do we do when we want to find the square root of a non-perfect square. Now remember, a non-perfect square is an irrational number because there really is no square root for a non-perfect square. For example, if I wanted the square root of 2, there's no number times itself that equals 2. You can get a number close, but you can't get all the way there. So if I'm working with a number like the square root of 2, I have to round my square root off. And by the way, there are 2 ways, there's actually 3 ways I know of that you can find a rounded square root of a non-perfect square. Okay, the easiest again is your calculator. And again, maybe your teacher in high school will let you use a calculator to do it. I know that Ethan Bowers did not let him at Jesuit. Okay, and I'm not sure about the ones who are at the girls' schools. I haven't tutored anyone at a girls' school in a while. But anyway, if I want to round this the way they taught at Jesuit, I would do it with guess and check. And again, what you would start with is an educated guess by asking yourself, what 2 square roots is the square root of 2 in between? Okay, well, it's perfect square roots. It's between the square root of 1 and the square root of 4. By the way, doesn't the square root of 1 equal 1 and the square root of 4 equal 2? And you say, well, there's no numbers in between 1 and 2. No, there's no whole numbers in between 1 and 2. There's an infinite number of numbers between 1 and 2. Because this is like 1 and 0 tenths. This is like 2 and 0 tenths. So you have 1 and 1/10, 1 and 2/10, 1 and 3/10, 1 and 4/10, 1 and 5/10, 1 and 6/10, 1 and 7/10, 1 and 8/10, and 1 and 9/10. Now, what I have to do is figure out which one of these, if I want to round the nearest tenth, I have to figure out which one of these is closest, okay, to 2 when I multiply it by itself. Now again, I can randomly pick one, and then if it's too big, go lower, and if it's too low, go bigger. Or I could use a kind of educated guess. Isn't it true that, that 2 is closest to 1 than it is to 4? So I would say an educated guess might be 1 and 3/10. And if you multiply 1 and 3/10 times 1 and 3/10, you get an answer here of, count 2, place behind a decimal, 1 and 69/100, okay, which is too small. So if you multiply 1 and 4/10 times 1 and 4/10, 16 carry your 1, 5, you get an answer of 1 and 96/100. And that's very close to 2, but it's still smaller. So I got to go until I get one that's too small, and then I got to see one that's too big. So let's try 1 and 5/10 times 1 and 5/10. 25 carry you 2, 7, 5, 1, 5, 12 carry you 1, 2, 2 and 25/100. So now I've found the 2 that were closest to it, one that's too small, 1 and 96/100, and one that's too big, 2 and 25/100. And the question is, which one of those is closest? And the answer is 1 and 96/100. Because if you took 2 minus 1 and 96/100, you would only be 4/100 away from it. If you take 2 and 25/100 minus 2, you would be 25/100 away. And 4/100 is way closer than 25/100. So to the nearest tenth, your answer is 1 and 4/10. Now, what if they ask you to round to the nearest 100th? Well, we now know, if I want to round the nearest 100th, we now know that the square root of 2 is between 1 and 4/10 and 1 and 5/10. And you say, well, there's nothing in between 1 and 4/10 and 1 and 5/10. There's an infinite number of things. How about 1 and 41/100, 1 and 42/100, 1 and 43/100, 1 and 44/100, 1 and 45/100, 1 and 46/100, 1 and 47/100, 1 and 48/100, and 1 and 49 hundredths, between 1 and 40 hundredths and 50 hundredths. So again, if I took an educated guess, I know it's going to be closest to 1 and 4 tenths. It was way closer to 1 and 4 tenths than it was to 1 and 5 tenths. So since it was way closer, maybe I start with 1 and 41 hundredths. That's about as close as you can get. And if you multiply that times itself, you get an answer here. 4 placed behind a decimal, 1 and 9,988 10,000ths. That's pretty darn close. And then if you did 1 and 42 hundredths, because you got to get one that's too high and one that's too low. You get an answer here. 2 and 164 thousandths. So both of these are pretty close to 2, way closer than 1 and 4 tenths was. All right, but to see which one is closest, you have to take 2 minus the smallest one, and it comes out to be 19 10,000ths. And then you take the larger one, 2 and 164 thousandths minus 2, comes out to be 164 10,000ths. And they're both close, but 119 10,000ths is closer, so this is the right answer rounded to the hundredths. And you go, you expect me to do this every time? Well, the teachers at Jesuit expect them to do it every time because that's the way the teachers at Jesuit taught to do it. But to be honest with you, I would not do it that way. What I would do, if I want the square root of 2 and I want to round it, I would use the algorithm. Again, the same algorithm we did for perfect square, square roots of perfect squares and of large numbers, and the square root we did for our square root of decimals that were perfect squares. So how would I round to the hundredths? Well, I'd add a decimal and 4 zeros. And you go, why 4 zeros if you want to round to hundredths? Because remember, I mark off every 2 places from the decimal. So every 2 places here count as 1 place behind the decimal. So when I bring the decimal up, this will give me the tens place, this will give me the hundredths place. So what number squared is closest to 2 without going over? 1. 1 squared is 1, remainder 1. Bring down the 2 zeros, double the 1 and get 2 with a blank behind it. 2 goes into 10 exactly 5 times, so 4 would be a better guess. And if you put a 4 here, put a 4 here. 4 times 4 is 16, carry a 1. 4 times 2 is 8, and 1 is 9. I can subtract if I borrow. And now I drop my next 2 zeros. I double 14 and get 28. And now I divide 2 into 4 goes exactly 2 times, so a better guess would be 1. 1 times 1 is 1, 1 times 8 is 8, 1 times 2 is 2. And you might say to me now, well, Mr. Dew, I did something wrong because I didn't get a remainder of 0. But the answer to the problem is you're not supposed to, because this is not a perfect square. You'll never get a remainder of 0. That's why I gave you so much practice of doing the algorithm when it was a perfect square before I'm giving you one where it's not. Because when it was a perfect square, you had to check. If it didn't come out with a remainder 0, you know you did something wrong. On these, you don't have a check, so you better make sure you do them right. Okay, by the way, now that I'm to the hundredths, I can round to the tenths. That's a 1, so the 4 stays the same, and I get 1 and 4 tenths. And what if I wanted to go to the thousandths? Well, I would just add 2 more zeros and repeat the process one more time. Double 141 is 242. 2 goes into 11 5 times. 5 times 5, put the 5 here too. 5 times 5 is 25, carry your 2. 5 times 2 is 10, and 2 is 12, carry your 1. 5 times 4 is 20, and 1 is 21, carry your 2. 5 times 2 is 10, and 2 is 12. And it's too big. And you say, well, I gotta go and erase it. No, you don't, because you don't need to know what this is. You just need to know if it's more than 5 or less than 5. And it's less than 5, so this stays the same, and your answer is 1 41/100. And again, I highly recommend you use the algorithm to round. But again, remember, for the algorithm, you walk off every 2 places. So if you want to round to the tenths, you go to the hundredths, which is 4 places behind the decimal. And if you want to round to the hundredths, you go to the thousandths, which is 6 places behind the decimal. So you have to add 2 zeros for each extra place so that you can round it. But if you know how to do the algorithm, and if you know how to round decimals, that's how you would do this. So now we know how to round square roots of non-perfect squares. So you'll have a homework with that on it. By the way, the homework is more than just that, but part of it you don't know how to do yet. So it's a skills test, and you only go as far as you know how to do. Tomorrow I'll teach you the other way to do it.